There are many, many people in the world who are studying these ancient rocks and their modern analogs and so forth. And the thing I sort of do is try to find microscopic organisms preserved inside stromatolites. And we've been able to do that, finding these microbes all the way back to 3.5 billion years ago. But they're pretty rare. And you say, well, why are they rare? Because there are billions of them, and they're building these things today. Why are they so hard to find in the fossil record? Well, the reason is that stromatolites like this, and many stromatolites, most all stromatolites in the fossil record, are made of calcium carbonate. That's a fancy word. The mineral is called calcite. And it's the stuff that limestones are made out of. And when the little calcite grains, they start off very small and then they grow as the limestone becomes, as the carbonate becomes more and more, it loses water and becomes more and more like a rock. And it's called lithification. So the thing is getting more and more sturdy as it loses water, and those crystals grow, and what they do is they crush the microscopic organisms. You can find layers in these carbonate stromatolites where the fossils once were, but now they're crushed down so small they have no cells in them. It's just the bits and pieces of organic matter that they were once made of. So if that's the case, how do we ever find microscopic fossils? Well, sometimes it turns out that carbonate rock can be replaced by quartz. Particularly a particular type of quartz. It's very, very fine grained. And that quartz comes in groundwater. Groundwater sort of seeps through these rocks and will sometimes precipitate and take the place of the carbonate, the calcite that was there. Well, when that happens, you get a petrified stromatolite. It's just like a piece of petrified wood. You know, everybody knows about petrified forest in Arizona, for example, where you can see the cells within the individual big logs. Well, those cells are made out of organic matter, but it's been petrified by quartz. Now, that's what happens also to some stromatolites, not very many. And so it takes a lot of looking to find those sorts of stromatolites that have been petrified by quartz. But you see, these microscopic organisms, they have cell walls just like a higher plant has. They have a good shape to them, and it's a definitive shape. It defines a given type of cyanobacterium. Sometimes they're balls, sometimes they're strings of cells. But they have these cell walls so they can be petrified just like a fossil plant.